See what happens if you have a positive and a negative charge. Will the same formula be able to work for this case too? Let's see. So if you have opposite charges, we know that opposite charges attract. So what would you think the direction of the force on 2 due to charge 1 be? Of course, it should be attractive, so it should be pointing in this direction. The opposite of it was before when the two charges were the same. So we're going to use the same notation, that this means the force on 2 due to 1. I'm going to claim that if we use the same formula exactly that we did before, everything will work out fine and the magnitude and direction will come out exactly correct the way we want it to, as long as you put Q1 and Q2 with their signs. We can see how this works. When you put Q1 with its sign, Q1 is positive, so it's plus magnitude of Q1. Q2 is a negative number, so we can write it as minus magnitude of Q2. If you plug these two back into the formula, you'll see you have a minus and a plus, and that means you have an overall minus sign that will go outside. We can bring it outside. We're left with this minus sign outside. We can put it with the r hat 1, 2 unit vector, and then everything inside this bracket that's left over is positive. So now we can determine what the direction of the force would be in this case. The direction of the force on 2 due to 1 will be a positive number. It's the direction of a positive number times this unit vector, this vector. And this vector is minus r hat 1, 2. Now what is a vector? When you multiply a vector times minus 1, what does it do to the vector? It just gives you a vector in the opposite direction. So minus r hat 1, 2 points opposite, exactly opposite to this vector. So that means it points from 2 to 1. And that gives exactly the correct direction that we want, right? So that means we got now the correct magnitude and direction by using the same kind of formula.